A standby generator requires a dedicated lightning protection system. This is crucial because generators, especially those located outdoors or connected to external electrical systems, are vulnerable to lightning strikes. Lightning strikes can induce very high voltage surges into the generator's wiring and connected equipment, causing significant damage or complete failure. The purpose of a lightning protection system is to provide a safe path for lightning current to flow to ground, bypassing the generator's sensitive components. Firstly, consider the placement of the generator. Generators positioned in exposed locations are at a higher risk. Secondly, understand that a lightning strike near a generator can still induce a surge, even if the generator isn't directly hit. A comprehensive lightning protection system typically includes several key components. One important aspect is air terminals or lightning rods. These are conductive rods installed at the highest points of the structure or equipment being protected. Their function is to intercept lightning strikes and provide a preferred point of contact, rather than allowing the strike to hit a more vulnerable area. Air terminals should be made of a conductive material such as copper or aluminum, and they must be properly sized to handle the expected lightning current. Down conductors are another vital component. These are heavy gauge wires or cables that connect the air terminals to the grounding system. They provide a low impedance path for the lightning current to flow to ground. Down conductors should be run as directly as possible, avoiding sharp bends or loops, which can increase impedance and cause the lightning current to arc to other objects. A proper grounding system is essential for effective lightning protection. The grounding system provides a low resistance path for the lightning current to dissipate into the earth. It typically consists of ground rods, ground plates, or a combination of both, buried in the ground and connected to the down conductors. The grounding system should be designed to meet the requirements of applicable electrical codes and standards. Surge protective devices, or SPD, are another critical element in lightning protection. SPD are designed to limit voltage surges and divert excess current to ground. They are installed at various points in the electrical system, such as at the service entrance, at distribution panels, and at individual equipment. SPD are rated by their surge current capacity, which indicates the maximum amount of current they can safely handle. It is important to select SPD with an appropriate surge current capacity for the application. Bonding is also an important aspect of lightning protection. Bonding involves connecting all metal parts of the structure or equipment together to create a common ground potential. This helps to prevent voltage differences between different parts of the system, which can cause arcing and damage. Bonding should be done with heavy gauge conductors and should comply with applicable electrical codes and standards. Regular inspection and maintenance of the lightning protection system is essential to ensure its continued effectiveness. The system should be inspected periodically for any signs of damage or deterioration. Ground connections should be checked to ensure they are tight and corrosion-free. SPD should be tested to verify they are functioning properly. Any damaged or worn components should be replaced promptly. Furthermore, it's important to follow relevant electrical codes and standards. The National Electrical Code, or NEC, provides guidelines for lightning protection systems. Local building codes may also have specific requirements. It's crucial to consult with a qualified electrician or lightning protection specialist to ensure that the system meets all applicable requirements. Selecting the appropriate components is also important. Air terminals, down conductors, grounding electrodes, and SPD should all be selected based on the specific requirements of the application. Factors to consider include the size and location of the generator, the expected lightning strike frequency, and the soil conditions at the site. Proper installation is critical for the effectiveness of a lightning protection system. The system should be installed by a qualified electrician or lightning protection specialist who is familiar with applicable codes and standards. The installation should be done according to the manufacturer's instructions and should be carefully inspected to ensure that all components are properly connected and grounded. Integrating the lightning protection system with the overall electrical system is also important. The lightning protection system should be coordinated with the generator's grounding system and surge protection devices to provide comprehensive protection. This may involve consulting with an electrical engineer to ensure that the systems are properly integrated. Also consider the potential for induced surges. Even if a generator is not directly struck by lightning, a nearby strike can induce a surge into the generator's wiring. This can damage sensitive electronic components and cause the generator to fail. SPD should be installed to protect against induced surges. Another important thing to note is that lightning protection is not a guarantee. While a properly designed and installed lightning protection system can significantly reduce the risk of damage from lightning strikes, it cannot eliminate the risk entirely. Lightning is a powerful and unpredictable force of nature, and even the best protection system can be overwhelmed by a particularly strong strike. It's also important to consider the cost of lightning protection. A comprehensive lightning protection system can be expensive, but it is a worthwhile investment for protecting a valuable asset such as a standby generator. The cost of the system should be weighed against the potential cost of damage from a lightning strike, which can include the cost of repairing or replacing the generator, as well as the cost of downtime. Finally, it's important to remember that lightning protection is an ongoing process. The lightning protection system should be inspected and maintained regularly to ensure that it continues to provide effective protection. SPD should be replaced periodically, as they can degrade over time due to repeated surges. In summary, protecting a standby generator from lightning requires a comprehensive system that includes air terminals, down conductors, grounding, surge protection, and bonding. The system should be designed and installed by qualified professionals and should be inspected and maintained regularly. While lightning protection cannot eliminate the risk of damage entirely, it can significantly reduce the risk and protect your investment. The National Fire Protection Association, or NFPA, provides standards for lightning protection systems. NFPA 780 is the standard for the installation of lightning protection systems. It covers the design, installation, inspection, and maintenance of lightning protection systems for buildings and structures. This standard provides detailed requirements for air terminals, down conductors, grounding electrodes, surge protection devices, and other components of lightning protection systems. It also includes information on bonding, shielding, and other methods of protecting buildings and structures from lightning. NFPA 780 is widely used by architects, engineers, contractors, and building owners to ensure that lightning protection systems are properly designed and installed. It is also referenced by many building codes and regulations. In addition to NFPA 780, there are other standards and guidelines that may be relevant to lightning protection. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards for surge protection devices. IEE Standard C62.41.1 and C62.41.2 recommend practices for surge voltage characterization. These standards provide information on the types of surges that can occur in electrical systems and how to protect against them. The International Electrotechnical Commission, or IEC, publishes standards for lightning protection. IEC 62305 is a series of standards that covers the general principles of lightning protection, as well as specific requirements for different types of structures and equipment. These standards are widely used in Europe and other parts of the world. When designing a lightning protection system, it is important to consider the specific characteristics of the site. Factors such as the soil resistivity, the height and shape of the building or structure, and the presence of nearby trees or other objects can all affect the performance of the lightning protection system. A qualified lightning protection specialist can conduct a site assessment to determine the best way to protect the building or structure from lightning. Soil resistivity is a measure of how easily electricity flows through the soil. Low soil resistivity is desirable because it allows lightning current to dissipate quickly into the ground. High soil resistivity can increase the risk of damage from lightning strikes. The height and shape of the building or structure can also affect the risk of lightning strikes. Taller buildings are more likely to be struck by lightning than shorter buildings. Buildings with pointed roofs are also more likely to be struck by lightning than buildings with flat roofs. The presence of nearby trees or other objects can also affect the risk of lightning strikes. Trees and other objects can provide a path for lightning to strike the building or structure. It is important to maintain a clear space around the building or structure to reduce the risk of lightning strikes. There are several different types of lightning protection systems. The most common type of lightning protection system is the conventional lightning rod system. This system consists of air terminals, down conductors, and grounding electrodes. The air terminals are installed at the highest points of the building or structure. The down conductors connect the air terminals to the grounding electrodes. The grounding electrodes are buried in the ground. When lightning strikes a building or structure, the air terminals intercept the lightning current and conduct it to the ground through the down conductors and grounding electrodes. Another type of lightning protection system is the charge transfer system. This system uses a network of electrodes to collect electrical charges from the atmosphere. The charges are then transferred to the ground through a grounding electrode. Charge transfer systems are designed to reduce the risk of lightning strikes by dissipating electrical charges in the atmosphere. A third type of lightning protection system is the early streamer emission or ESE system. This system uses an air terminal that is designed to emit an upward propagating streamer. The streamer is intended to attract lightning strikes to the air terminal. ESE systems are controversial because there is limited evidence that they are more effective than conventional lightning rod systems. When selecting a lightning protection system, it is important to consider the specific needs of the application. A qualified lightning protection specialist can help you choose the best system for your building or structure. Lightning protection is an important part of electrical safety. By protecting your building or structure from lightning strikes, you can reduce the risk of damage, injury, and death. Generators, transfer switches, and associated wiring should be protected by properly sized overcurrent protection. According to the NEC, overcurrent protection devices, such as circuit breakers or fuses, must be readily accessible. Overcurrent protection must protect conductors against overloads and short circuits. The ampacity of conductors must be sufficient for the load they carry. Proper grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and de-energize the circuit. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. The generator should be installed in a well-ventilated area to prevent overheating. The generator should be kept clean and free of debris. Regular maintenance is essential to ensure the generator operates safely and reliably. The generator should be inspected regularly for any signs of damage or wear. The oil should be changed regularly. The air filter should be cleaned or replaced regularly. The spark plugs should be inspected and replaced as needed. The battery should be tested and replaced as needed. The generator should be tested under load regularly to ensure it is operating properly. Only qualified personnel should perform maintenance on the generator. Before performing any maintenance, the generator should be shut down and disconnected from the power supply. Safety precautions should be followed when working on the generator. Wear appropriate personal protective equipment such as gloves and safety glasses. Use insulated tools. Never work on the generator in wet conditions. Be aware of the potential hazards of working with electricity. If you are not comfortable working on the generator, contact a qualified electrician. Understanding the different types of generators is also helpful. Standby generators are designed to provide backup power during a power outage. Portable generators are designed to be moved from one location to another. Inverter generators produce clean, stable power that is suitable for sensitive electronic equipment. Choosing the right size generator is important. The generator should be sized to meet the power needs of the equipment it will be powering. An undersized generator can be overloaded, which can damage the generator and the equipment it is powering. An oversized generator can be inefficient and costly to operate. Consider the power requirements of all the equipment that will be powered by the generator. Add up the wattage of all the equipment. Choose a generator that has a wattage rating that is greater than the total wattage of the equipment. Consider the starting wattage of some equipment. Some equipment, such as motors and compressors, require more power to start than they do to run. The generator must be able to provide the starting wattage of this equipment. Consider the voltage requirements of the equipment. Some equipment requires 120 volts, while other equipment requires 240 volts. Choose a generator that provides the correct voltage. Proper ventilation is crucial to prevent carbon monoxide poisoning. Never operate a generator indoors or in an enclosed space. Carbon monoxide is a colorless, odorless gas that can be deadly. Generators produce carbon monoxide as a byproduct of combustion. If you must operate a generator near a building, make sure the exhaust is directed away from the building. Install carbon monoxide detectors in the building. Test the carbon monoxide detectors regularly. Be aware of the symptoms of carbon monoxide poisoning. These symptoms include headache, dizziness, nausea, vomiting, and confusion. If you suspect carbon monoxide poisoning, get fresh air immediately and seek medical attention. Safe storage of fuel is important. Store fuel in a well-ventilated area away from heat and sparks. Use approved fuel containers. Never store fuel in the same area as the generator. Dispose of fuel properly. Never pour fuel down the drain or onto the ground. Be aware of the environmental regulations regarding fuel storage and disposal. Contact your local fire department or environmental agency for more information. Regular inspections can help identify potential problems before they become serious. Check the generator for any signs of damage or wear. Check the oil level. Check the air filter. Check the spark plugs. Check the battery. Test the generator under a load. Keep a record of all inspections and maintenance. This will help you track the performance of the generator and identify any potential problems. Follow the manufacturer's recommendations for maintenance. The manufacturer's manual will provide detailed instructions on how to properly maintain the generator. Failure to follow the manufacturer's recommendations can void the warranty and may damage the generator. Proper planning is essential for safe and reliable generator operation. Consider your power needs. Choose the right size generator. Install the generator properly. Maintain the generator regularly. Follow all safety precautions. By following these guidelines, you can ensure that your generator operates safely and reliably for years to come. Also be aware of emergency procedures. Know how to shut down the generator in an emergency. Know how to disconnect the generator from the power supply. Know how to contact emergency services. Keep a list of emergency phone numbers near the generator. Be prepared for a power outage. Have a plan in place for what to do in a power outage. Know where the generator is located. Know how to start the generator. Know how to connect the generator to the power supply. Have a supply of fuel on hand. Have a first aid kit available. By being prepared, you can minimize the impact of a power outage. Lightning protection system should conform to UL 96A, the standard for installation requirements for lightning protection systems.